This is the video going over the quiz 3 review. So first of all, it says, what is the most specific name of the quadrilateral that state all the justifications for it being that shape? Find the length of the sides, the diagonals, and the slopes of the sides and diagonals, okay? So we're going to do all of this. So what I'm going to do first is draw the shape MNOP, and then we're going to talk about it. So I've gone ahead and drawn MNOP. Now we're going to figure out what we can say about the different sides. So first of all, I'm going to look at it and say, it kind of looks to me like it's a square, but we have to prove that. So we're going to find out what the length of the sides are, what the slopes of the sides are, what the lengths of the diagonals are, and what the slopes of the diagonals are, okay? So the first thing I want to do is look at MN here. So I'm going to count one, if I push the pen, 1, 2 up, and 1, 2 over. Okay, so going from there, right? So if I look at the length of MN, that's going to be equal to 2 squared plus 2 squared. So that's going to be equal to 4 plus 4, and that's going to be the square root of 8. So looking here at NO, 1, 2 over, 2 down. OP, 1, 2 over, or 2 down, sorry, 2 left. And MN, 2 down, 2 over. Okay, see that? So we can tell that all these sides are the same length because the rise and the run are the same. So we could say MN is equal to NO, which is equal to OP, which is equal to MMP. Okay, we're going to talk about what that means in just a minute, but all the sides are congruent. So actually, let's go ahead and type that out. This had to do with lengths, right? So I'm going to write that there, lengths, okay? Now we're going to talk about the slopes of those sides, okay? So MN rises from left to right, so we know that's going to be positive. So MN slope is going to be equal to 2 over 2, which is equal to 1. OP, same thing, okay? So both of those slopes are the same. So then when we look at NO is falling from left to right, so that is 2 down and 2 right, okay, so that's going to be a -1. Those are perpendicular slopes, and MP is the same as that, right? So now, sorry, MP. So now we can say that MN is perpendicular to what's next to it, NO, and NO is perpendicular to OP, and OP is perpendicular to MP, and then we can say MP is perpendicular to MN. Okay, so we can say consecutive sides are perpendicular. So we're going to type that next, okay? So I'm going to put that up here. Consecutive sides are perpendicular. PRP, PERPENDICULR. Could be great if I could spell, right? Now let's talk about our diagonals. So we've got the diagonal NP and the diagonal MO. Okay, so let's see if we can find what the length of those are. So the length of the diagonal of MO, we can count it, right? 1, 2, 3, 4. That's equal to 4. And the length of NP is also 4, right? NP is equal to 4 as well. So that means MO is equal to NP. So that means our diagonals are congruent. So we're going to type that. Let's compare the slopes of them. So can you tell that you should be able to tell that they are perpendicular because one is vertical and one's horizontal. So we can also say that MO is perpendicular to NP. Okay. So we're going to type that as well. So we're going to say the diagonals are congruent. Maybe if I can get my thing back in here. And the diagonals are perpendicular. Could be great if I could spell, y'all. All right, now what does all that mean? That means that this is a square, okay? That's what that tells us. All the sides are congruent, consecutive sides are perpendicular, diagonals are congruent, and diagonals are perpendicular. So if all those properties are true, then this is a square. All right, now we're going to go on to this next one. Given points M and OP, and O and P changed here. So again, this looks like a rectangle, but we have to prove that. So that's what we're going to do again. Now we already have MN. We've already found MN and OP, right? MN and OP are going to be the same length over here. So we already know those. We've already solved for that. So MN, go ahead and write that. MN, you know what? Let's give us some space to type over there. So when we're ready, I'm going to do MN. Okay, pen. MN is equal to OP. Why? Because both of those are 2 over 2, right? So that's both of those are equal to the square root of 8. Okay. Now let's find NO and MP. So here we have 1, 2, 3 over and 1, 2, 3 down, right? So NO is equal to 3 squared plus 3 squared. So that's going to be equal to 9 plus 9, which is square root of 18, right? So this is a square root of 18. And once again, notice 1, 2, 3 down, 1, 2, 3 to the right. So that means NO is going to be equal to what? MP. So that obviously means opposite sides are congruent. So now let's talk about our slopes again. So we're going to talk about the slopes of these lines. So we've got the slope, and we already found the slope of MN, remember? MN was equal to 2 over 2. That was equal to 1. And that's the same slope as OP. So MN slope is equal to OP slope, right? Okay. Remember, we're talking about slopes now. Now, if we talk about NO slope, this is falling from left to right, right? So this is going to be 3 down and 3 over. So that's a -1. And that's the same slope that we have for MP. So MP and NO slopes are the same, okay? So what does that tell us? That tells us that consecutive sides, again, so we would say, like we did before, we would say MN is perpendicular to NO, and NO is perpendicular to OP. Then we would say OP is perpendicular to PM, and we could say PM is perpendicular to MN, right? So then we can make the statement that consecutive sides are perpendicular. So now let's talk about our diagonals again. So now we're going to talk about this NP here. So let's talk about it first. NP. So if we do this one, it's 1, 2, 3, 4, 5 down. It is falling from left to right. So that's -5, and it's 1 over, right? So that's -5, okay? And we're going to find the length of these in a minute too. So actually, we could do them both at the same time, right? So let's do this. Let's do it this way. So that was the slope, right, of NP. So we'll say NP, and then we're going to do 5 squared plus 1 squared, right? That's going to be the length. Let me see if I can move this over, y'all. Maybe. Nope, not going to let me choose it. You know what, we'll just do it over again in a minute. Well, that's going to be the square root of 26, right? Okay. So that's the length, and this was our slope of NP. Okay, now let's talk about MO. Same thing right here, MO. Okay. So with MO, again, we're going this time down 1 over 1, 2, 3, 4, 5. So that's going to be our 1 squared plus our 5 squared. So once again, that's the square root of 26. So that tells us that NP is equal to MO. That means our diagonals have the same length, right? So then we're going to also find the slope here. And this one was 1 down, 5 over. Okay, so that was still negative. So those are not reciprocal slopes, right? So what else can we say about these then? We can say that the diagonals are congruent, right? So that's what we're going to say next. So thus, I would say, because opposite sides are congruent and consecutive sides are perpendicular and the diagonals are congruent, that we can say that this is a rectangle, right? Maybe if my thing will type. I don't know why it's not typing. Pause. So again, the shape's a rectangle for all the reasons stated. All right, so the next one I plotted was MNOP. This one looks to me like it could be a parallelogram, right? So again, we're going to do the same things. We're going to find the length of MN, OP, NO, and MP. We're going to look at our diagonals. We're going to look at it all. Okay, same way we did before. So MN, we know, is, again, 1, 2 up, 2 over. So we know that MN is going to be equal to OP, 2 down, 2 over. So that MN is equal to OP, which is equal to the square root of 8. Okay, found that several times. Now we need to look for NO. So this time we're going over 1, 2, 3, 4, 3. Wait, I can't count today. Apparently, y'all. So we're going over 1, 2, 3, 4, 5, and down 1, 2, 3. So when we look at NO, it's going to be 5 squared plus 3 squared. Right? So that's going to be 25 plus 9, so that's equal to the square root of 34. And this one is the same. 1, 2, 3 down. 1, 1, 2, 3, 4, 5 over. So that's also equal to MP. Okay, so that means opposite sides are congruent, right? So that's what we're going to do next. Now let's look at our slopes, okay? So we're going to do slopes next. Okay, so here we've got MN. MN is 2 up, 2 over. So that we know is 2 over 2. That's equal to 1. That's the same as OP, right? So those slopes are the same. And then we got NO. So on NO, it's falling from left to right, so it's going down 3, right? NO went down 3 and over 5. And that is the same as MP, isn't it? Okay, so is there any relationship there? Nope, so that doesn't help us at all. So now we're going to look at our diagonals, and we're going to find the midpoints of our diagonals, okay? So to find the midpoints of our diagonal here is NP. Let's do this in red, actually. Maybe if I can get my pen to work. NP. Okay, so if we look at the midpoints now of NP. So point N was -1. That's my x value. P was 2 divided by 2. That's going to be 1/2. So that's my x value. Then my y value is 1 and -4. So 1 minus 4 divided by 2. That's -3/2. Okay. So that's my ordered pair right there. 1/2, -3/2. So let's see if it's the same for the midpoint of the other side. So now we're going to look at MO right there. Okay. So we're going to do the same thing with M. So we're doing -3 and O plus 4 divided by 2. That's 1/2 again. So at least our x values for sure the same. Now let's look at the y. That's -1. O is -2 divided by 2. So that's -3 over 2 as well. So our midpoints check out. So we could say that these are, this is a parallelogram, right? Because why? Because our midpoints, the midpoints of the diagonals are the same. Midpoints of diagonals congruent or the same. Okay, so what shape is this? This is a parallelogram. Now, you can also look at these slopes. These slopes were not perpendicular, so there's no way it could be a rectangle or square, right? So that's the other thing. And you could find the length of the diagonals to see if it would be a rectangle as well. And we can look at these numbers right here, right? So if we do rise over run here and compare it to the rise over run there, if they are not congruent, then it can't be a rectangle. All right, so our last one over here, again, I plotted MNOP, and so we're going to do the same things here we've been doing. So we're going to find the length of MN. This time, this is a little different. So MN, 1 over 1 up, 1 up, 2, 2 thirds, 1 up, 3 over. 1 squared plus 3 squared. That's going to be the square root of 10. See if the opposite side's the same. That would be 1 down, 1, 2, 3 over. Yep. So MN. Great if I could write today, y'all. MN is equal to what? MN is equal to OP, right? Let's keep going. This one is 1, 2, 3, and 1 down. And this one is 1 down, 1, 2, 3 as well. So they're all equal. They're all going to be the square root of 10. So that means this is also equal to NO, and this is also equal to MP, right? So we could say 4 sides are congruent, right? All 4 sides are congruent. That means this is a rhombus, okay? But let's go on and do the diagonals as well. So if we look at NP here, how long is NP? That's equal to 2. And what is its slope? Undefined. And it's vertical. Okay, so, and then if we look at MO, MO is right there. And MO is equal to 6, and that's a horizontal line, so it's got a slope of 0. Okay, so we can say here that NP is perpendicular to what? MO. So if the diagonals are perpendicular, it's another confirmation that this is what shape? A rhombus. You got it right. Okay, so let's go ahead and write that. So we have proven that this is a rhombus because all sides are congruent and the diagonals are perpendicular. We could find the slopes. This was 1 over 3. This one was negative 1 over 3. So obviously those slopes are not perpendicular. Okay. So that's just another way for us to confirm that this was a rhombus. All right, let's go on to the next question. Find the area of the following shapes. Find the area of the following shapes. Put your answer in standard form. So on this one, it's asking for area. Okay, pen, you can write for me now. Not writing. I don't know why it's not writing up there. Area. So that's what we're going to talk about. So we're going to use the box method here to find the area of this rectangle and that triangle. Use this tool we call a box, and I'm going to do this in descending order. So I'm going to write this in descending order. Negative 2x squared, 4x, and 7. And then over here, going to do the same thing. X squared minus 9x and minus 3. And I told you guys if you do it this way, then your like terms will show up in the diagonals. So x squared times negative 2x squared is negative 2x to the 4th. I'm going to do these in different colors here. 4x times x squared is going to be 4. Well, I thought I was going to. 4x to the 3rd. I'm going to go down here to the negative 9x times the negative 2x squared. So that's going to be 18x to the 3rd. Okay. Now we're going to go to the 7 times x squared. So that's going to be 7x squared. 4x times negative 9x would be negative 36x squared. Then we got negative 3 times negative 2. That would be a positive 6x squared. All right. Then we're going to do 7 times negative 9. That's negative 63x. And then 7 times, 4x times negative 3. That would be negative 12x. And then we've got our other term down here, and I'm going to do it at black again. 7 times negative 3 is negative 21. So now we're just looking for our like terms and we're combining them, right? So when I do this, I get negative 2x to the 4th. We're going to combine the red. 18 and 4 would be plus 22x to the 3rd. Then we've got 6. We're subtracting 6 from 36. That would be 30 plus 7. Wait. Let's just do it this way. Negative 36 plus 13. That would be 23. Okay, so this is going to be minus 23x squared. Then we're combining our blue terms. So 6 and 1 is 7. And 2 and 3 is 5. So that's negative 75x. And then we got our minus 21. So that's our answer there. Now the difference between this one and the next one, this was area is equal to what? Base times height, right? So we have our base and our height, but the area of a triangle is base times height divided by 2. Okay, so we're going to have to use our box method over here, but then we're going to use it a little bit differently because once we get our answer, we're going to divide by 2. Okay, so I'm going to use the box again. Here again, I'm going to write these in order. Well, the top one already is x squared minus 12x and 7. Over here, I'm going to do 4x and minus 6. Again, write it in descending order. So x squared times 4x is 4x to the 3rd Then I'm going to do negative 12x times 4x would be negative 48x squared. X squared times 6 is negative 6x squared. Then once again, we're going to do our 7 times our 4x, that's 28x. Negative 12x times 6 would be 72x. And then 7 times negative 6 is negative 42. So now we're combining our like terms again like we did before. So we got our 4x to the third. And then we're combining the negative 48 and the 6. So that would be negative 54 x squared. Then we got 72 and 28. That would be 100. Is that right? 70. Yep. 100x plus 100x. And then we got our minus 42. Now what you need to not forget about this is that we have to divide all of this by 2, right? So our final answer is going to be 2x to the third minus 27x squared plus 50x minus 21. Okay, that's our final answer because we have to divide everything we did before by 2. This next question says find the equation that is perpendicular to 9x plus 3y equals 12 passing through the point 3, 6. Okay, so the first thing we want to do with this is put it in y is equal to format. So let's subtract the 9x from both sides. That's going to give us 3y is equal to negative 9x plus 12. Divide everything by 3. When we do that, we get y equals negative 3x plus 4. So what are we interested in here? That negative 3 right here. So our slope, our given slope was negative 3. So what's our perpendicular slope? Okay, that's what we want to ask. So our perpendicular slope is going to be equal to positive 1/3. Right? Okay, so then what we're going to do is we're going to plug these values in for x and for y. Okay, so when we do that in the equation, y equals mx plus b. So that's 6 equals 1/3 of 3 plus b. So 1/3 of 3 is 1, so this is 6 is equal to 1 plus b. Then we have to subtract 1 from both sides. So b is equal to 5. So that means our equation is y is equal to, remember, we're going to plug back in our new m and our new b. So it's going to be 1/3 x plus 5. All right, so the next one says match the images with the correct transformation, translation, rotation, reflection, 1, 2, and 3, and then tell what kind it is, basically. Okay, indicate the type. All right, so what we're going to do first is we're going to connect these vertices. So we got, I'm going to do this in red, A to A prime, maybe, A to, my pen is not wanting to work today, y'all. A to A prime, B to B prime, C to C prime. Okay, are those lines all the same length? You're right, no. Okay, so what do we want to do? We want to bisect them, right? So right there, so that's a reflection because the lines are parallel, but they are not congruent, right? And the line of reflection is what? So this is a reflection, so that's a 3. So we're going to say 3, and a reflection over what? Over the y-axis, right? Okay, so let's look at this next one. Same thing. We're going to do the same thing. A to A prime, B to B prime, C to C prime. Now, what do you notice about those 3 lines? They're parallel and they're congruent. Okay, so that means this is a translation. Okay, so we're going to say this is a 1 in a translation by what? So let's just go from A to A prime, okay? We're going to go left, right first. Okay, so if we go from A to A prime, we're going 1, 2 left, 2 left, and 1 up, right? 1 up. Now let's also write that as a vector and as a rule. So x, y becomes what? X minus 2, y plus 1, and then our vector would be written negative 2, comma 1. Okay? All right, now let's look at our next one. So our next one, we're going to connect them again, the vertices. So we're going to connect A to A prime. And if we do A to A prime like that, and we do B to B prime, what do you notice? Boom, right there. What did you notice? Whoops, my line's not very straight, but y'all get it. what's going to happen? They're going to cross, right? Okay, so now let's go back and let's see if we can figure out what kind of rotation this is. So let's go from A to A prime, or from the origin to A, right here. And then let's go from the origin to A prime. Well, what kind of line do we have right there? It's a straight line, right? So this is a rotation. We know it's a rotation because the line's crossed, right? But we also know it's a 180-degree rotation because it creates a straight line. All right, so let's look at this next one. Again, we're going to do A to A prime, B to B prime, C to C prime. Okay, so what do you notice again? Parallel lines, right? But not what? They are not congruent. Okay, so what we're going to do is we're going to draw a line that bisects them all. And what is that line? This is a reflection. And a reflection was 3. And this is what? Over the line y equals x. It's rising from left to right. Y'all notice that? Okay. All right, so let's look at this next one. A to A prime, right there. B to B prime, right there. C to C prime, right there. Well, they don't cross, but if I extended the line, kept going this way, they would. See that? They would, okay? So that's the key to seeing the rotation thing. You can extend your line. So, because remember, the others are parallel lines, right? So now, again, let's do this. Let's go from the center, from the origin, from here to A prime, or to A, and then from there to A prime. Okay, so what's that look like? 90-degree rotation, right? So which way, though? Remember, we go this way naturally, okay? So this would be a 270-degree rotation. Rotation, great. Okay, what was a rotation? I don't remember. That was 2, right? So this is a 2. Or a 90-degree clockwise rotation, okay? Because we could go the other direction, right? Clockwise is this way. Okay. All right, so we got one more. A to A prime, B to B prime, C to C prime right there. 3 parallel lines, but are they congruent? You got it. The answer is no. So we're going to bisect them. So again, what is this? This is a reflection, right? So we got another reflection. And this one's what? Over the x-axis. There you go. Number 5 says, given the points x and x prime, identify the translation. Okay, so this is, we haven't done this like this, so let's talk about this. So if we're going from -3 and we're going to add an x to it, and that's going to equal -1, right? Okay, and then we're going to do -7 plus our y equals a -10. So what do we do here? We just solve for the variable, okay? So here we're going to add 3 to both sides. So x is going to be equal to 2. And here we're going to add 7 to both sides. So y is going to be equal to what? -3. So what does that really mean? So if we were to write this, this means we're going 2 right and what? 3 down. We could write this as a vector like this, right? 2 comma -3, or as a rule. X comma y would be what? X plus 2, y minus 3. Okay? Those are the different ways you could write it. All right, the next one says reflect the point Z over the lines below. Write the rule and then the image of Z. Tell how you would reflect them graphically. Okay? So if we're reflecting over the y-axis, if you remember, I told you guys that you change the x, right? So this would be -x comma y. So our new Z would be 4 comma 5. And what would that look like graphically? So we were 4 to the left, so aren't we going 4 right of the what? The y-axis, okay? So you're just moving your point 4 right of the y-axis. The x value would, the y value would have stayed the same. Okay, so let's do the next one. X-axis, this one is going to be x comma -y, right? So here, this time, we're not changing the x, so that's going to be -4, but we are changing the sign of the y. So this time, we're going to move what? 5 down from what? The x-axis. axis. That's what you're doing, okay? So the line y equals x is going to be, you just flip them, okay? Yx. So we're just changing them. So this is going to be 5 and this is going to be negative 4, okay? So what do you do here? What I said when I wrote down this was I said flip the x and y and then plot it. Flip x and y and then plot. That's going to be the easiest way to do it, okay? Now, your last one is the line y equals negative x. So this is negative y comma negative x. So they flip and change signs, right? So this time we're going to have negative 5 comma positive 4, okay? So this one you're going to flip and change the signs, right? And then plot. Okay? All right, so our last set of questions says write the rule for what changed and then state what type of transformation occurred with the images below. So what I want to talk to you all about is what do you see and how does it change? So we're going from here a 3, 1 to a 3, negative 1. So what changed? The y value. You're right. So our rule would be x comma y becomes what? The 3 didn't change, so it's still x, but the y changed to negative y, right? So what is that a rule for? Isn't that a reflection over the x-axis, right? Okay. So the next one, again, we're going to look at the change. 3, 1 changed to 3, negative 1. So the signs of both changed. So we're going to say x, y became what? Negative x, negative y. What is that? That's a 180-degree rotation. Got to know these rules, guys. Okay? So the next one says negative 1, 3. So what happened this time? They flipped, right? So they flipped and the y value changed sign. So here again, we're going to say x, y. So that becomes negative y comma x, right? Double checking my stuff because I can't see what's up there. Negative yx, yes. So what is this? This is a 90-degree rotation, or what other kind? A 270-degree clockwise rotation. Remember, they're always going to be opposites of each other. Okay, so the next one is negative 1, negative 3. Okay, so negative 1, negative 3. So again, we're going x, y, and our original point was 3, 1. Okay, so that means they did what? They changed and they flipped, right? So this is going to be negative y comma negative x. So that is a reflection over the line. Over the line, y equals negative x, right? Okay. All right, the next one is 1, negative 3. So once again, they flipped, right? So we're going to do that first. I'm going to say y comma x. Now, did the signs change? Which sign changed? So it was 3, 1. Okay, so it became what? That changed, right? So the y value became negative. Okay. So this one, if it's negative yx, is what? A 270-degree rotation, right? Or a 90-degree clockwise rotation. All right, F says negative 3, 1. Okay, so that's the same order. So we're going to say x comma y. This becomes x, y, but what sign changed? The first sign changed. Okay, so if we change the x, where did we reflect over? We reflected over the y-axis, right? Okay. All right, last one, 1, 3. So it was 3, 1, and it became 1, 3. So this is x. Y becomes what? Yx. So this is a reflection over the line, what? Y equals x, right? Reflection over y equals x. That's it, guys.